So today is our journal 1.4, solving variables on both sides, and we're going to go through the steps. So step number 1 says simplify the equation by moving the parentheses. How do we remove the parentheses? What do we typically have to do? What's the operation for that? What's that called? What is it?
We multiply the parentheses.
Mm-hmm. What's the math term for that? Sandra? Distribute. Yeah, we're going to distribute. We're going to distribute. I don't like the way that word looks. Let's try it again. So what that means is we're just going to distribute. I know that we're cutting these in half, so I'm going to try and write that below here. Distribute. Remove those parentheses. We use distribute. Okay. Combine like terms. Remember, like terms are same variable with the same power or constants. Move the variable terms. It says from the right side to the left or left side. I don't care what side you put your variables on. I want you to do what works best for your brain. My brain does not like working with negatives. So I will always move the smallest variable term to the other side. So that could be on the left side. It could be on the right side. It doesn't matter. Again, you use what works best for your brain. Then I move the constants. And then lastly, you move the coefficient, remove the coefficient by using opposite operations. Okay. So the unique thing about this is sometimes when you solve equations with variables on both sides, you have what's called special cases and something happens. So you could have an instance where you have infinitely many solutions, and that could be something like 2 times x minus 1 equals 2x minus 2. When I distribute on the left, I get 2x minus 2 equals 2x minus 2. You guys notice something about both sides of the equation? What do you notice? Yeah, they're identical. That's why this is called the identity. Okay? They're identical. That's why this is called the identity. And then sometimes, and so this means, let me scoot back for a second. So when you have something like this where you have the exact same thing on the left side as the right, when they're exactly the same, identical, you get infinitely many solutions. It just means that any number that you put in there for x will make that equation true. Any number, so it's infinitely many. Sometimes you might get something that is not solvable, right? It has no solution. And that could look like maybe 4 times 2x minus 3 equals 8x plus 7. So when I distribute on the left, well, that gives me 8x minus 12 equals 8x plus 7. In order to solve this, I would have to get the variables all together on the same side, right? So in order to do that, I'm going to subtract 8x from both sides. And what happens when I move the variables to one side, I end up canceling out the variables, and I get a statement that looks like that. So when does negative 12 equal 7? Never. Never. So this is called inconsistent because it has no solution. This has no solution, right? So when you have something that has no solution, you end up with a false statement. That might help you think about it. This is false. When you have something that has infinitely many solutions, you would end up with, if I had subtracted 2x from both sides here, I would have ended up with a statement that said negative 2 equals negative 2, which is true. Okay? So inconsistent or no solution means you're going to get a false number statement. Infinitely many or the identity means you're going to get a true number statement. Okay? Does that make sense? Have you guys seen that before? Okay. No? Yes? It's kind of? Okay. I'm going to pause for a second because I see some of you are still writing that down. Raise your hand if you need more time with that. I got you, girl. Thank you, ma'am. Okay, so let's do example number 1. So our first step says, hey, you got to get rid of your parentheses. And we said we do that by using the distributive property. So 40 minus x equals, let's see, 4 times negative 3 is negative 12. And 4 times negative 6 is negative 24x. And then I'm going to add a 6 there. All righty, let's see. Combine like terms. Are there any terms that I can combine together on the left side?
You can combine the negative 12 and the positive 6.
I can combine the negative 12 and the positive 6 on the right side. I'm not changing the left side at all. I'm just going to rewrite it. 40 minus x equals. And what is negative 12 and a positive 6, Owen?
It is negative 6.
Good job. Negative 6 minus 24x. So what do you want to do next? It doesn't matter to me. Someone choose. What do you think, Ariana?
Plus x.
Okay. Add x to both sides. I love that. So I have 40 equals negative 6 minus 20. Whoops, I said 20 and I wrote a 3. Sorry about that. Minus 23x. Okay. What do you want to do next, Tim? What would you do?
Plus 6 to both sides.
Good job. Opposite operation. Add 6 to both sides. 46 equals negative 23x. God bless you.
Thank you.
Last step, Ken. By. Divide by what? What are we dividing both sides by? We always divide by the number that's a what? Attached to the variable, right? So we're going to divide both sides by a negative 23. This cancels out. So x equals, let's see, what is 46 divided by negative 23? Negative 2. So how many solutions does this have? What does it say x equals? What does it say x equals? X equals negative 2. That means that this only has one solution. This has one solution. The solution is x equals negative 2. Nothing tricky about it, okay? It only has one solution. I'm going to scroll down to example number 2. What in the heck is going on here? Okay. So what do you think we need to do first? Say it again. We still have to distribute to get rid of all of those parenthesis groupings. And there's a lot of them, right? We have 3 sets of parentheses. So let's see. 9 times x is 9x. 9 times negative 3 is negative 27. I have plus 2 all over 7 equals, let's see, 3 times x is 3x, plus 3 times 5 is 15. A negative 2 times x is negative 2x, and negative 2 times 3 is negative 6. I still want to follow that step that says combine like terms. So if you notice on the fraction, I still can combine those terms. And then I can group my x's together and my constants on the right. So the fraction piece is going to be 9x minus 25 over 7 equals 3 minus 2 is 1x. 15 minus 6 is plus 9. Now, here's where it gets crazy. I can't do anything to the numerator of this fraction. I can't do anything with this until I get rid of the what? Until I get rid of that 7, the denominator. Yeah, you're right. You're right. You're both exactly right. So how do I get rid of a denominator? What did we say we do? Yeah, we have to multiply both sides by 7, right? So I'm going to multiply this by 7. This side is getting multiplied by 7. Notice that I'm putting that 7 on the back side because I don't have room on the front side. This is still a distribution problem. Okay, this is still distribute. So when I multiply by 7 on the left side, whew, all that goes away, and I just have 9x minus 25 equals, when I multiply by 7 on the right side, 7 times x is 7x, and 7 times 9 is 63. What do you want to do next? Anybody? Tim?
Plus 25 to both sides.
Sure. Let's add 25 to both sides. I think that sounds great. So 9x equals 7x plus 88. Okay. Lissandro? Yeah, good job. Subtract 7x on both sides. I love it when you guys say on both sides. I want you to remember that whatever you do to one side, you do to the other. So 2x equals 88. Last step. Owen?
Divide both sides by 2.
Yeah, divide both sides by 2. So here I come up with x equals 44. How many solutions does this have? 1. This has 1 solution. Okay, only 1 solution. Are we good with that? Raise your hand if you need more time. Your nails look pretty. Let me know when you're ready, hon. Thank you, ma'am. Okay, so let's see what happens on this side. So example number 3. So example number 3, we have 2 sets of parentheses. So that means I'm going to have to distribute through. 2 times 3x is 6x. Good job, Michelle. 2 times 7 is 14. Minus 4 equals 5 times 2x is 10x. Good job. 5 times negative 8 is, good job, minus 4x. Okay, let's see. On the left side, I can group together my constants. And on the right side, I have some x's that I can group together. So the left side simplifies to 6x plus 10. And the right side simplifies to 6x minus 40. So what do you want to do next? Ariana? Subtract 6x from both sides. So when I subtract 6x from both sides, I get this statement that says 10 equals negative 40. When is that true? It's never true. So first thing you guys see is I put a slash through my equal sign because they're not equal. That's not true. And then I write below it, no solution. And I just abbreviate it like that. I do want to kind of put a box around this. And I want to talk about this because you guys are going to be so familiar with solving equations that actually you're going to be able to tell if something has 1 solution, no solution, or infinitely many right when you get to a binomial on one side and a binomial on the other, right? We talked yesterday about a binomial, 2 terms on each side. So notice that when I look at this box, I have the same variable terms on both sides. And that's the 6x. But what you also should notice is that I have different constants. Remember, constants are just numbers. And the different constants are the positive 10 and the negative 40. So when you have the same variable term on both sides, so this is when you have a binomial equals a binomial, and you have the same variable term on both sides, you know that those are going to cancel out. If your constants are different, that means that they're not equal to each other, right? And so that should be an indicator to you that there's no solution. That's how you can identify that, okay? Questions about that one? Raise your hand if you need more time. Okay, I'm going to go on to example number 4. You guys are doing great. So example number 4. Let's do some distributing. Whoops. We're going to distribute. Remember that's a negative 2 going across there. Distribute. So let's see. 5 times 2 is 10. 5 times negative 4x is negative 20x. Good job. Plus 12 equals, let's see, 14. Negative 2 times 10 is negative 20x. And negative 2 times negative 4 is positive 8. Yeah. Okay. Let's see. I can combine my 10 and my 12. 22 minus 20x equals, and I can also combine my 14 and my 8, which is 22 minus 20x. So if I were to add 20x to both sides, yeah, it is. Add 20x to both sides, you would see that these cancel out and I get a number statement that is true. 22 equals 22. But again, just like in the last example, take a look at this box right here and tell me what you notice. What do you have on both sides? Yeah, you have the same variable terms and the exact same constants. So that's, again, when you have a binomial equals a binomial, you have the exact same variable terms, exact same constants, you're going to have infinitely, and I always abbreviate this, many solutions. Infinitely many solutions.